Hello everyone. This video covers lecture of limit of the calculus. So in this video we will cover definition of the limit, properties of limit, limit of infinite function, define limit at infinity and continuity. So actually what is limit? Limit is a word is used in everyday conversation to describe the ultimate behavior of something as in the limit of one's endurance or the limit of one's patience. So limits like we say barrier or concentrates in conversation. But in mathematics, the word limit has the similar but more precise meaning. So when we in calculus we define limit like this. You can see in the picture in the screen that the limit x approach 3 of f(x), limit of f(x) is approaching 3 equal to 10. It means given a function f(x) means we have one function f(x). If x approaching 3 causes the function to take value approaching or equaling some particular number, such as 10. 10 is the constant. Then we call 10 the limit of the function and we write like this. Okay, in practice, the two simplest way we can approach 3 are from left or to right. So see this picture in the real line. The 3 is in the middle and x approaching to 3 from the left we put 3 power minus, from the right 3 plus. Okay, so from the left and right 3 become, for example, 3.01, 3.001. From left become 3.29999. But what we write that is 3 is approaching, x is approaching to 3. Actually, x is not approaching to exact 3. Okay, so such limit, if a plus or minus, we call it one side limit. One side limit means plus, we have plus from the left or from the right. Okay, this is one example, one finding a limit by the table. So we have this function, the limit of 2x plus 4, this function 2x plus 4 and x approach to 3. The limit of x 2x plus 3 as x approach 3. So we make two tables. One table is from left and one table is approach from right. From left, one is from right. So you can see it's going to, the limit is 10, almost getting to 10 by increasing the x. So by increasing the x, you can see it's approaching from left and right to 10. Okay, so the definition of limit: a function f(x) is said to approach to constant L as a limit when x approaches a, as below. As we said in the previous slide, that limit of function f(x) as x approaches a is constant L, where x the function we assume a corresponding set of value and x is independent variable. Okay, limits of the form like this is called two sides limits. If like this is two-sided limits. If plus and minus, here we have here plus minus or or for example plus, we call it one-sided. If we don't have, let me delete, we call it two-side limits. Since the value of x get close to, its approach means get close to, never reach to a, but x is getting close to, for both left and right. Two-sided is from both left and right. You imagine this, this one from left and from right. Okay, so x from left and right, one-sided. This is two-sided. From left hand side in the real line approaching to 3. Okay, limit which consider value of x on only one side of the a are called one-sided. Means like this, as I said, plus of or minus from left, only from left or only from right. They call it one-sided limit. Okay, this is left hand limit because this is minus, and it is positive become right side. If positive, if this one positive become right sided. Sorry, right hand limit. Okay, how to read the limit of fx as x approach a from the left side? Okay, as x gets to closer and closer to a from the right side. A, okay, x less than a, y less than a, because it's going to a from the left side. This is minus. If from right is positive. Okay, so this side is x less than a, is not equal. From the side x bigger than a. Okay, thus we have left sided like this, right sided like this. Okay, for left sided, let's say it's k, the constant is l, and the constant is k and l, respectively, for minus and positive, for left sided and right sided. Okay, and in order for limit to exist, the limit from left and limit from right must be exist and equal. So we say that the limit of one function exists if k equal to L. For all fx, means fx exists, what we have, so the limit exists. We have limits, we say limits exist in this condition. X exists in this condition, that x exists, and L left-sided limit and right-sided limit are equal, means k equal to L. In this condition, we can define and we can say limit exists. Okay, this is example. Okay, find limit x2 plus 1 as x approaches to 0. It's obviously 1. Okay, so this is in the graph you can see the visualization. This is x2 plus 1, x2 is here, right? So it's shifted 1. Okay, so x less than 0 means x approach to a minus x approach to a plus. So you can see in the table that is approaching to 1, right? Or is approaching to 1. Approaching, and don't look at this. I mean the y. See, I mean the y. Y is 1, x is 0, y is 1. Here. Fine. Okay. Example number 2. The closer x gets to the 0, the closer the value of fx comes to 1. It's more pushing toward the 0, so the fx will be pushed to 1. Okay. These limits could have been determined by simple substitution. So one of the way to calculate or to find out the limits, simply consider substitute. Okay, 0, x is equal to 0. Assume it is 0. So if x equal to 1, right? So we can say this one is equal to 1. Okay, so if you said minus 0 or positive 0 or from left or from right is achieving, so it's equal to 1. So in this condition, we x2 plus 1 is a function which is exists. Negative and positive are say equal and 1. So we can say the limit exists. Okay, example number 3. So we have a square of x, so we have square of 4 big Y because x approaching to 4, simply substitute. Or here we can simply substitute. Okay, we put just 6, the answer will be 4 for this function when x approach to 6. Okay, properties of limits. Let be a real let a be a real number that suppose that limit x approach a limit fx x approach a equal to L and for g equal to k. Okay, then we can separately find f limit of fx and jx and plus and minus. We can multiple, we can take the fraction over, and I think here should be not a, here should be h power n. And see, you can find the limit of functions and apply the operation. Find the limits of the function first, then apply the operation. Find the limit of the function first, then apply the operation. So for instance, limit of x2 plus 1, simply I can put 3 here, 3 plus 1, 3 power 2 plus 1, or I can find x2 separately, limit 1 separately, and plus to each other, same as here. I can find separately top one and downside, then the answer will be 1 over 8. Okay, so but we have one condition. If the result will be 0 over 0 or infinity over infinity, we will have two methods to calculate. So if we face something like this, we have to calculate the limit in another way around. Okay, if simply we substitute, becomes 0 over 0 or infinite over infinite. If simply we substitute, Okay, so we use these two methods to find the real answer. This is not the real answer. If we find 0 over 0, it's simply substituting x inside fx and x inside gx, or gx is it's not the real answer if we face 0 over 0 or infinity over infinity. So when this case happens, we can factorize the numerator and denominator, means top side and down side, and simplify the fraction. Okay, multiplication of conjugates method. So when it's happened, we can find the conjugates of the function. Okay, factorization. Okay, how the factorization works. Okay, we have the limit of x2 minus 9, x minus 3, x approach to 3. So if I simply substitute 3 here, will be 9 minus 9, 3 minus 3, so 0 over 0. Okay, so from this I understand, oh, this is a special case. So what should I do? I have to simplify. I have to find the extent of these x2 minus 9. If you have this, means x2 minus 3 power 2. Simply I can say x minus 3, x plus 3. Downside I have x minus 3. Okay, so in top side and downside I have similar, so I can ignore them, or I put 1 in here, right? So if I only find the limit of this, means substitute x inside 3, so I can find the answer too. So the real answer is 6, not 0 over 0. Another one. This one example for multiplications. Okay. How does it work? If I simply put 1 in here, become 1 minus 1, become 1, become 2, become 1. There's something in here. I think 2 here is extra, because here we don't have 2. Why? In 2 is here is extra, as I mentioned, because square of 1 minus 1 become 0, right? If you have 2, then 0 will be 0 over 1, right? So I think 2 here is extra, so which is 0, not a special condition. Okay, we don't have 2. Okay, if we don't have 2, so we have 0 on 0, 0 over 0 condition. So what we have to, we multiple to the downside, both sides. Why? Because it's equal, right? It's the same thing. If I delete this part, will be same as the question. So we multiple these two. What we have in here on the downside, we have same terms, square x 1 1. So we, if you have plus and minus, if I have this condition, the two expressions, same terms, only the difference is positive and negative. So first one, power 2 plus, minus the other term, 1 over 2. So this is x minus 1. Okay, downside I have x minus 1. 1. Top side I have x minus 1. Okay, so this is 1, this is 1, so I have only x plus 1 over 1 on the top. Okay, limit of this x approach to 1, so I simply put 1 here. Sorry, it's come until here, finish only x on the square, so 1 plus 1 over 1 equal to 2. That's the answer. Limits of the infinite function. So if x, okay, so in the condition that 1 over 0 means infinite in mathematics, in limit. Okay, if you have 1 over 0 means is approaching to infinite. So if it is plus means right side you are going to, for example, here 0 to the right side, positive infinite. If it is negative, x approach to negative, so it will be minus infinite. Okay, left side and right side. Okay, let's say it is odd number. We have this function 1 over x power r. For example, odd number like 3. So if x approach to 3 means 0 minus, so will be minus. But if it is even, so will be x power, for example, 2. So 0 minus power 2 will be, because this is even become plus infinity. We know that, for example, with this concept that minus 3 power 3 is equal to 3 power 2, right? So equal to 9. But if minus 3 power 3 is minus 7, that's why if r is odd number, it's minus. Okay, let's see one example. So find limit of 1 over x2, x approach to 0. This is the function actually. So if x approaching from the left side, so it's going to plus infinity. From the right side also is going to plus infinity. So what's the answer? Plus infinity. Why? Because x is 2. Okay. Okay, another example. Given if x1, x minus 2 from the right and from the left going to 2, the x approach to 2. Okay, let's see. Let's draw we already have visualization. You can see from the left or from the right x approaching to 2. But in the 2, if from the left is going to minus infinity, but if from the plus is going to right side, is going the y going to plus infinity. So from the left side, left-handed or left-sided is minus infinity, or left-handed or left-sided is plus infinity. Okay, what we have here, define limit as a infinity if now the x going to infinity. Okay. Okay, that one I said x infinity, sorry, 1 over 0, the limit of 1 over 0 is infinity, right? So 1 over infinity is 0. So if downside is going to be infinite, the answer is 0, okay? But if the limit x approach to infinity, x equal to a and b, then a and b is equal. This is the theorem. If one function x going to infinity goes to the constant, of course, is a and b's limit is very obvious. Okay, for positive integer, this one I mentioned, if the limits divide each term by x, power of the denominator. Let's see. If x and jx is infinite over infinite, divide each term by x to the highest power of a denominator, like this. Find x. This is our function and infinite. If we have this, so we will have, if we substitute only infinite, we'll have infinite over infinite. We have this condition number C. Okay, so here the highest power is x3. Downside also is the highest power is x3, but it's a dominator. So means divide to this only. Divide to this. Highest power of denominator. All the terms. Okay, after we divide to x power 3, each term, we will have this function after simplifying. So we substitute infinite. Here become 0, here becomes 0, here becomes 0, here becomes 0. The answer is 2, obviously. Another example. Okay, the highest power of the downside, denominator is the downside. Okay, so x power 3 is the highest. So if we simply just substitute here, substitute x, so we'll have infinity over infinity. Why? Because this is infinity, this is infinity, this term is infinity, right? Infinity plus 21 is infinity, right? Infinity plus 1 is infinity. So infinity over infinity. But we have x3 in the downside. This is the highest power. So what should I do? Divide all the power, all the terms to x3. After that, I simplify it. After simplifying this term, I will have this line. Now substitute. Now we can substitute. Will be 0, 0, 0. Why? Because any value over infinity is 0 in the limit. Okay. So 7 plus 0, 0, 0. 7. This is 0, 0, 0. So top side we have 0, downside we have 7. So the answer is 0. Another example. What is the highest power? Oh, okay. First simply substitute. Will be this condition. Infinity over infinity. So we have infinity over infinity. Condition number 3. What we have to do? what we have to do? Divide each term by x to the highest power of the denominator. Denominator is downside, difficult to pronounce for me. So x is the highest power. Okay, x2 over x, each term you divide to x each term. Okay. So after simplify, I have this expression. So substitute infinity, this one becomes 0, the top side become infinity over 12, because this term is 0, so we have the answer is infinity. So okay, continuity, last one. Continuity, okay, a function, actually continuity is a condition of a function. So a function, let's say define y equal to fx, that can be graphed through its domain with one continuous motion of the pen, that is without lift the pen. Okay, means I can draw like this, not drawing in this way. So means when you are using the pen, you can draw it. But if there is a gap, right? If there is a gap, you cannot continuously draw. You have to lift up your pen and continue it. Okay, it's as an example of continuous function. These are the continuous. This is continuous function. This is not continuous function. This is not continuous function. This is continuous function. Okay. A function of a function f is the name of the function, is continuous at the point x equal to c if first function c should be defined, second limits of function should be defined, then limit of f(x) should be equal to if we substitute c inside fx. This is the definition of continuity. So three conditions. First, c f of that points, if we substitute that point, should be exist. Limit of fx should be exist. How the limit exists? Left side, from left side and right side equal. This one we had before. You can refer how limit exists. Limit fx equal to fc. fc means c substitute inside fx. Actually, this is fx. Okay. Type of discontinuities. Removable discontinuity. It is the type of discontinuity in which that particular point left side limit and the right side limit are equal and defined, but there are no equal to the limit that of the points. Means if we have from left side is exists, if we have go from right side is exists, but is not equal to that particular points, means there is a gap. Okay, another type is jump discontinuity. This is in this discontinuity, left hand and right hand limits do exist and are undefined and finite, means not infinite, finite means have particular number, but they are not equal. So it means they are not equal. Right sided are not equal. This one is here, this one is here. This is L, it is K, for example. But L and K obviously are not equal, right? Number 3, infinite discontinuity. Infinite discontinuity is a discontinuity in which the left side and right hand or both do not exist or are infinite, like this. Around x is not continuous. Why? Because y is going to infinite, right? Continuity on the closed interval. Definition of continuity on the closed interval. Okay, let's f be defined in the closed interval, means there is a range for f. F is continuous on the open interval x, in the open interval x, if like this condition, from the left side, right-handed of the left side, for example, this is A and B. F should be continuous from here, sorry, this one should be deleted, here and here, like this. This one is right hand and this one is left hand, right? So this one is right hand plus this is minus left hand. So in that condition, f is continuous in the interval A and B. Okay, then f is continuous on the closed interval. Moreover, f is continuous from the right of the A, continuous from the left of the B. Okay, let's see this example. Discuss, we have this function. Okay, discuss at each point, continuity at each point, 0, 2, 3, 3.5, 4. Okay, let's point 0. Point 0, fx exists, f0 is exist. From the right hand, we have a function fx. So f is continuous but is right-handed. Okay, number 2. So you can see there is a jump. So fx is not equal to f2. f2 is here, limit is here. Okay, so f2 is not continuous, is discontinuous, is not continuous because limit is not equal to f2. The function failed, part 3 of the test. So limit fx is exist, yes, this is the condition. We have three conditions. f2 is exist, limit exists, but limit and function is not equal, so fail. Number 3 is not function because have the intersection in 2 points when I have, so f3 is not exist even, does not exist, see, does not exist. So the function failed on part 2 of the test. Okay, 3.5 is continuous because 3.5 is here. If 3.5 exists, limit also exists, and they are equal. But when you look at 4, so 3.5 is this one fail, this one fail. For 4 we have to look at a minus, like this, because it's the end of the interval. So sorry, a is here 4. Okay, function fx f4 exists, limit from the left side exists, and they are equal. So for x4 equal to 4, all three conditions are satisfied, so it's continuous. Okay, another exercise. Given a graph of fx, graph of fx is like this, is shown in the picture. Determine if x is continuous at x equal to -2 here. -2 is here. 0, 3. Obviously, 2 we have jump, so discontinuity jump. 0 if x and exists, limit of 0 exists, and they are equal. So at 0 is continuous. S2 is not continuous because we have jump. And x3 is removable. Continue, discontinue, because if x and limit are not equal. Okay, is a jump discontinuity is -2. 2 is 0 is continuous because everything is, all the conditions are satisfied. And for 3 is removable. Discontinuity. X3 is here, so they are not equal. So it's jump to here. Okay, that's all for this lecture. Thank you.